pretty excited to be here and present on this topic of network visibility. I want to really focus the presentation on a solution called network access modeling and give you like practical advice. And I'm going to tie those up to the cybersecurity performance goals from the CISA agencies. So my name is Berthier. I'm the co-founder and the CEO of Network Perception. At NP. We design and develop software solutions for critical infrastructure in the field of network visibility. We've been doing that for more than 7 years. We came out of the research from the University of Illinois with funding from DOE and DHS. So I'll start by giving you a short introduction on the biggest challenges in securing OT. How has CISA responding to those challenges by introducing the cybersecurity performance goals? And then I'll spend the bulk of the presentation on showing you through 5 CPGs how we can leverage a solution like network access modeling to help you accelerate your ability to make sure to meet those goals. So if you look at the latest SANS cybersecurity OT survey that was launched last year, you can see that one of the major challenges are around the technical integration between OT and IT, either on the OT technology themselves or around security solutions specifically that are not well integrated with the needs and priorities that you can find inside OT. That leaves a lot of organization with exposure and lack of strong best practices on those OT devices. So we see a vast majority of organizations just not having the proper segmentation in place or the proper ways to limit exposure of their critical services to the rest of the corporate network or even to the internet. So the cybersecurity security agencies have introduced the CPGs as a way to improve that status. They recognize that essential cybersecurity best practices are not sufficiently applied. And so they laid out 4 key challenges in their introduction. So many organizations have not adopted fundamental security protections. Small and medium-sized organizations are left behind. There's a lack of consistent standards and cyber maturity across the critical infrastructure sectors. And then OT cybersecurity often remain overlooked and under-resourced. So they launched the CPGs that are divided across 38 goals into those different buckets that you can all recognize. So there are typical cybersecurity areas from security of accounts, devices, data, governance and training, management of vulnerabilities, as well as managing supply chain and third party, how to respond and recover. And then they have 3 additional goals in other categories. So for today's presentation, I want to focus on 5 of those CPGs. The 5.1, mitigating known vulnerabilities, 5.4 and 5.5 to understand the exposure of network services, 7.4 around documentation of network topology, and then 8.1 around network segmentation. I'll start with the topology, then segmentation, and then go back to the management of vulnerabilities. So before I dive into those goals, I want to tell you more about what network access modeling is and is not. So when we talk about network visibility, most of us have in our head an idea about network traffic monitoring, which is a really important way to get visibility on traffic that's happening like in real time in your network. So you're going to instrument your environment with sensors, or you're going to configure a tap or span on your network devices to be able to collect live traffic, and based on that visibility, understand exactly how your network is behaving. What I want to talk to you about today is different. It's called network access modeling. It's a very complementary approach to network traffic monitoring. And by modeling, we don't actually look at any live traffic, or we don't need to scan anything in the network. We rely on the config file of the network devices, so firewalls, routers, and layer 3 switches, to build a very precise reference architecture diagram, a model of the environment. And we can then send queries to that model in order to understand connectivity. And the advantage of network access modeling, that's extremely fast to implement. It's not a heavy lift where you have to spend months putting sensors and agents. You can start right away. You just need a copy of your config files for some of your firewalls, and you can expand your horizon there by importing additional devices. So the way this is usually deployed, it's at the back end of an existing configuration file management system or backup system. So you have your network devices in your OT environment, firewalls, routers, switches. You keep a backup or a copy of those configuration files, and then you can either import them offline, so by hand into your network modeling solution, or you can put a connector with a scheduler, which will, on a weekly or daily basis, import the latest version of those files and refresh and build that model of the network that can be used then for visualization to understand your topology, as well as making sure you have a good review of your access rules, access policies, network segmentation, and producing reports that are for your security compliance teams, as well as your as auditors, in case you have internal audits or external audits. So let me show you through examples with those 5 cybersecurity performance goals, how that works in practice. I'll start with the goal 7.4, the documenting of the network topology. This table is from the CPG checklist that CISA published a few months ago. So organizations should maintain accurate documentation describing updated network topology and relevant information across all IT and OT networks. Periodic reviews and updates should be performed and tracked on a recurring basis. And so if you look at the mapping in the top right corner, this is mapped to the NIST CSF PR IP-1. So there's different ways to address this CPG. The first manual way would be to ask your team to produce some visual diagram by hand. This can be time consuming. And then when you are complete with those diagrams, often they are outdated because changes in the network made them obsolete. So what I want to show today is an automated way through this network access modeling solution. So let me switch here to my web browser. So this is the solution is called NPView. So I imported right before the presentation 1, 2, 3, 4, 5, 6, 7, 8 config files from firewalls, and we can now select those firewalls, and we can see this is a Cisco firewall. The raw file that was imported is right there. So the software extracted information from the different block of interfaces, object groups, as well as access lists to build a model. And from that model, now we can send queries such as understanding the topology. So let me go to the manage view. I'll look at the initial topology map. So what you can see here is that the model, based on the information from the config file, shows this layer 3 map. We have our different firewalls. The blue clouds are representing interfaces or broadcast domains, and then connected to those broadcast domains, we have endpoints. So those are all the workstations, servers, or industrial equipment that we have in our environment. And this map can then be exported to a visual diagram or PDF, or can be kept inside the application, as well as refreshed over time when you have changes to your configuration. This means that you have this reference architecture diagram ready and accurate, because this is ground truth based on the way your network devices are configured. So this helps to automate the addressing that performance goal. The next is 8.1 network segmentation. That's building on top of the topology we just built. So Recommended action, all connection to the OT networks are denied by default unless explicitly allowed. And necessary communication path between IT and OT must pass through a DMZ or a jump host to make sure that we don't allow direct connectivity from an untrusted or low security zone into our critical environment. So this is done with the solution by labeling the different zones in the map and then leveraging path analysis to understand all those connectivity that are available inbound and outbound for those zones. So if I look back here, I can go to my second topology view where I created the different zones. So we have an external network at the top. We have a main corporate network in the top left, a backup corporate network on the right, two DMZs, main and backup, and then our electronic security perimeters. So ESP1 in the bottom left, ESP2 in the bottom right. And the colors of the zone can be adjusted to reflect the criticality or the impact rating of a different environment. And now that we have that information, we can select a given zone and run analysis, like send queries to the model to understand connectivity in and out of that zone and make sure that we have proper use of our jump host. So here we have a jump host here that we can look at path inbound. So I see I have remote desktop available from the corporate network to the jump host. And then from the jump host, if I look at the outbound, I can follow that remote desktop connection from the jump host all the way to my ESP. So we see that for remote desktop in this specific configuration, we have the correct use of our segmentation rules. The other way we can look at it is through the rule table itself. So I can select a firewall and then open the access rule table. Those will be all the policies, access policies defined inside the firewall. I can see the binding, so which zones are bound to which interface, source, destination, service. In case of a next-gen firewall, you have also some filtering on the sometimes on the application layer, permit or deny rules, and then very importantly, the justification. Like, why do you need this rule to be allowed? And then also making sure that you have, as the CPG stated, an explicit deny by default, which we don't have in this example, to make sure that everything is denied by default, and then you allow on a need-to-know basis. And we can export the table. We can also add comments. So if you have, for example, this first rule here as SSH from the ESP to the jump host, you may want to make sure that the justification is correct. And then you can add a comment that says reviewed, and this has been verified. So you can keep track of your assessment as you go through meeting that cybersecurity performance goal. Next, I want to talk about the CPG 5.5, which is to limit OT connections to the public internet. So the goal is to make sure that you don't have any OT assets that are exposed to the public internet, unless you have an exception that's documented, that's really required for operation. And if you have such an exception, you want to make sure that you have strong authentication with multi-factor in order to prevent abuse of that connection. So we're following the same exact workflow here that we did for the segmentation, which means that we can select any critical asset and then or the entire zone and look at the inbound connectivity to see if we have any network paths that are possible from external zones down to the ESP. So in this case, we see we have 1, 2, 3, 4 services plus a connection allowing any port. So starting from the bottom, we have 8531, which is used by Windows Update. So we can see here that we have Windows Update service from the corporate network all the way to the ESP. We have our remote desktop that we reviewed before, which is allowing a jump host from the DMZ to remote desktop into the ESP. Then we have this port 443 with multiple sources possible. They are highlighted in blue in the map, and then one of them actually is from the external zone. So that's breaking our policy there. We identified a path that's possible from the external environment, crossing two firewalls and reaching that ESP. And this is the type of connectivity that will be really difficult to identify if you were to look at file config files individually. But now that we can group them into the same model, into that view, the tracing of those paths allow us to uncover them. So we can go to the root cause, like why do we have this path now? So we can select that path and then select the rules that are allowing this path. We have this PCC remote as source, any destination. So maybe we want to filter further our destination and fix that rule. So we can put a comment here and then mark the rule as to revise, send that to a firewall team, and then re-import the modified configuration once the issue has been fixed. Next one is SSH TCP/22, same as remote desktop. This is interactive from our jump host all the way to our ESP. And then the last one is this IP-any, which is our backup link, the VPN between the main site and the backup site, allowing data transfer in case of an issue in the main site. And there's a debate there whether or not to allow any port or to specifically allow ports and services that are only used in that ESP based on applications deployed. So depending on the size of your environment, you may go one way or the other. The risk with any, of course, is that if one of the environments gets compromised, there's just like complete open door for an attacker to exploit and go to the next zone. So for 5.4, no exploitable services on the internet, I want to show you another feature, which is called the stepping stone access map. So this one, like 5.5, is really around understanding which ports and services are accessible and from where. So the path analysis is our way to answer that, but we can connect paths one to the other in what we call a stepping stone map to get more insight into the exposure and the correct deployment of our segmentation inside this environment. So to do this, I can select a node, go to inbound, select stepping stone, and then the model will show me based on every path possible in that environment, which assets can connect directly to this target. Those are highlighted in red. So everything in the backup site, we have our jump host in a DMZ, and we have an additional host in a corporate network with direct connectivity to that target. The host in orange are one stepping stone away, which means that if an orange node like this one in the external network were to be compromised, then the attacker would have to also compromise a red node before getting to the target. And then the yellow nodes are two stepping stones away. So you have to use an orange node and then a red node as jump host in order to get to that target. Super powerful visualization to summarize a complete access policy in one picture, and that helps a lot in terms of explaining to your team or to different groups how your segmentation is being enforced, and also to identify potential gaps that you were not aware of, where you thought you were like 2 or 3 layers deep in terms of access policy to protect a given service, but actually you're closer that you imagine in terms of how many hops from the internet to your critical asset. Okay, and then last one, 5.1, mitigating non-vulnerabilities, which is building on the last two that I explained with the exposure, is to be able to combine vulnerability information with the path analysis to understand which vulnerabilities should be patched first. And so what I've done here before the presentation was to import a scan file from Nessus. So in addition to the config file of the firewalls, I went ahead and imported this Nessus scan report, and that led to those little shields here that are displayed for some of the assets. So, for example, here this firewall has 2 vulnerabilities identified, CVE 9999 and CVE 2003. We can get more information on that vulnerability. And now, with this information directly available in the map, I can understand which nodes have exposure to the internet, and if they are vulnerable. Like if I have 2 different nodes, one is exposed, one is not exposed, that can help me to prioritize my efforts in terms of patching and patch the one exposed first in order to address this cybersecurity performance goal. All right, and so in terms of takeaways, I invite you to engage in a conversation with your team about those CPGs. I think they're a great resource that CISA published in terms of helping organizations to be focused. They have different documents. They have the CPG document themselves, plus the checklist that I've presented here in the discussion. They're a great way to identify gaps. They each have mapping to the NIST CSF. So if you're already using the NIST CSF as your internal cybersecurity control program, you can map that back to the CPGs and get a scorecard on how much sure you are for those different areas. And then in terms of strengthening your procedures for cyber hygiene and meeting the bar that are stated by the CPGs, network access modeling is a technology that can really help to accelerate the documentation of your network topology, as well as the understanding of whether your network segmentation is sound, correctly configured, or whether you have overly permissive rules, gaps in terms of your firewall definition, misconfiguration that could expose some of your cyber assets, some of the vulnerable ports and services to untrusted zones. And with this, I'll be happy to answer question you may have. You can also feel free to email me. My email is at the bottom here. And we have a knowledge base at kb.network-perceptron.com with much more information on that solution, with also some example tutorials. So feel free to go check it out.
Robin, great presentation. Love that you also put a way to connect with yourself as well there at Network Perception. So I want to summarize a couple things here, and I want to get right into the questions because we have a few lined up for you. You cool with that?
Absolutely, yeah.
All right, sounds good. So just thinking back over your presentation, I mean, a lot was shown here, like looking at assets from a visual perspective. We're all visual creatures, so having that available to us is much better than the network diagram on a napkin at a bar someplace. So love the fact that you can actually visualize your network there. And as I'm speaking, any questions that are coming in as well, please put those into the Slack solutions discussion, and I'll queue those up as well for Robin. So the first question that I have is this. In your demo, you showed the interfaces and a map of firewalls in a network. Then you did show was that the ACL rules of a firewall that they asked? And if that's the case, it was okay. So that was ACL pulled from a firewall. Excellent. So the next part of that question that came in is this. Is this a real-time pull of data? And can this be used for quarterly or maybe monthly review of firewall rules? And can it be done safely on an ICS firewall?
Great question. So I start with the end. So the safe aspect of this, because it works offline, it's extremely safe, right? There is no connection to your critical environment. You just need a copy of your firewall configuration. So there's no risk or any widening of your attack surface when you use a solution like a network access modeling. For the real-time part of your question, so it really depends how often you want to import the latest version of your configuration files. If you do that by hand, you can have a process to update on a monthly basis. If you connect the network modeling solution like NPView to your backup system, you could go as often as daily. So every day you have the latest version of your environment.
Okay, excellent. And you can load those files. So take those from your firewall or maybe a safe backup, Would that be fair? And then load them in the tool to review them that way?
Yep, you can drag and drop in the tool offline on an offline workstation, and you start with that initial map. And then when you have the map, labeled with the metadata, the zones, you can then start connecting it to your source of config file, and it updates automatically.
Okay, excellent, excellent. I'm going to go right into the next question here. We got a few here. Does the Tenable reports have to be loaded individually, or can they be automated to be loaded in once the scan is completed?
So same answer as for the config file of the firewalls. We have a system of connectors, and we can connect to a shared folder. So if you have, a shared folder, we can SSH to that shared folder and import all the files we discover in that folder. Or you can also, we have a connector for a Samba, shared drive. So if you put those scan reports into a Samba drive, we can connect and import them automatically.
Excellent. Okay, great, great. Continuing on with the next question that we have queued up here. Does network perception view use netconfig or netconf, or what other tools may it use to map out the firewall connectivity along with the routers?
So we have developed parsers for each vendors of those network devices. So we have 24 different parsers for all the usual suspect, right? Cisco, Palo Alto, Fortinet, Checkpoint. Actually, on knowledge base is a section of everything we support. But yeah, we don't rely on another software to convert those files. We take the raw configuration and we parse them, whether it's XML for Palo Alto or it's just ASCII text for Cisco. We parse that, and then we convert everything to the standardized format inside the platform, and then we use that to build the model.
Okay, and that's 24 firewalls you can parse today, correct?
24 brands of firewalls, correct? Firewalls, routers, and some of them are OT specific.
That was where I was going to go next. Yeah, so ruggedized firewalls, ICS specific, can dissect ICS protocols. So that's correct. So there's some within the 24 that are ICS specific protocols that you can dissect.
Correct. So we build a library over time, right? So as our user base grew, we had requests from different OT users. Of course, they wanted to start importing Hirschman or RuggedCom or Schweitzer, and so we developed parsers for those.
Excellent, excellent. Sounds good. So we got a few more minutes left. So the questions, Robin, are going to keep coming. Yeah.
Okay. Sure.
All right. Sounds good. How much manual effort is needed to position the networked devices on that map? And does it give you a topology map at any point? I think we might have answered this one, because if I understand your answers correctly, it's when you load the config, that's how you generate that map, correct?
Yes, so the map is automatically generated, but then you can arrange the layout. So you can customize and draw zones or put labels on endpoints. You can say those are my critical endpoints. And then you can arrange the layout. So you can move those around to clarify or the software does a pretty good job to spread out the layout, but you can customize that. And in terms of efforts, it takes, for a medium-sized network, less than an hour to put your map clean. And then it's something you do once, because once you've done it, you can just keep importing files and it will update the map, but the layout will stay.
Excellent. And looking at the map that you've demoed on screen, it looks to be somewhat aligning with Purdue. You have the upper levels possibly, and they can be relabeled, I'm assuming, as well. Here's my ICS DMZ level 3.5. Here's my 3. Here's where my HMIs are. Okay, so you can adjust that in the product. Okay, fantastic.
Exactly. Yep.
Excellent. Okay, I'll keep going to the next one here. You showed in the demo network traffic such as RDP. Was that allowed traffic, or enabled rules, or actual traffic patterns seen on the ICS network?
Great question. So it's not live traffic seen, because we don't monitor traffic in any way. It's really a possible traffic. So it's a possible network path that we identified based on your rules in your firewall. So we know that someone can connect through RDP because your firewall is allowing it. So it's a types of possibilities, not actual traffic.
Okay, good, great clarification, because to understand, if you mentioned that that's an access way for an adversary, that's also a possible increase of risk surface as well. So you can look at it that perspective. Yeah, great. Let me see what else is here. How did you get the endpoint data? Was that from configuration files? That was the question there. I'm not sure the
Great
context.
question. So we first get it from the config files, based on IP addresses that we discover inside the config, like on object groups or rules, if you hard code IP addresses in the rules. So we extract all the IP addresses we discover, and then we put them in the map as endpoints. But then you can also enrich the map with your scan data or with the hostname file, or even like a show ARP from a switch. And so we have parsers for all those different file formats. So we can enrich the map and put all the endpoints you have if you put those enrichment data in the view.
Right. Okay. Okay. Excellent. And lots of questions. So we got a couple more minutes. So I'm just going to clue this up with probably the one or two last questions. And one of these questions is this: how does network modeling or monitoring work without increasing the attack surface for control systems?
Yeah, so that's tied to the question earlier on whether this was safe as a solution to deploy. And yeah, because it works offline, doesn't connect. So it's on-prem first, like there's just nothing going to the cloud. It's on-prem, it's offline, and the connectors we have to download the files automatically from your backup system, those will use like a read-only service account. So there's no ports exposed or no new access to be able to to add to your policy in order to get the system to work.
Right. Okay. Excellent. Do you see any industry standards for network monitoring or modeling being universally adopted today? And if so, can you explain a bit about that? If not, what's keeping that standard from happening?
Yeah, that's a good question. I think network access modeling is pretty recent. So my prediction is that we'll see it making its way through different standards. I know like NIST, the CSF is working on version 2. So we may see some references to using both, those two sides of visibility that I presented earlier, right? The network traffic monitoring and network traffic modeling. Earlier this year, we saw regulation being pushed for network traffic monitoring. And so I can, in the next 2 to 5 years, we'll see the same type of, push for also modeling, because it's such an accelerator for you to gain that network visibility that we need.
I got one last question here. I think we addressed this already. I'll just run it by you though, just to make sure. Doesn't the use of network monitoring or modeling technologies introduce its own risks or vulnerabilities? How can it be addressed? I think we've covered that with your previous answers with, extracting a configuration files, but did you have anything else you'd like to add to that?
No, I think, yeah, we covered it. It's offline, on-prem. No need to create new accesses, and you can be up and running right away. There's just no need to wait for deploying any sensors or any agents. It's just a copy of your config, and you're up and running.
Good to go. Okay, great. Robin, I want to thank you for this great presentation. Anybody has any additional questions, please connect with Robin in the solutions discussion channel there. And Robin, thank you again. Really appreciate you coming by.
Thanks, Dean. Great to be here. Thank you.
All right. Thanks so much.